We have this Janet girl, snow is falling onto her driveway. The F equation is how fast the snow falls onto her driveway, cubic feet per hour. So that's how fast it's going. It's kind of like a derivative equation. And then the G, and also cubic feet per hour, is how fast she's removing the snow from her driveway. So part A just says how many cubic feet of snow have accumulated on her driveway by 6 a.m. So all you care about is that F equation. That's your accumulated of snow equation. So you're going to integrate the F of T in between 0 and 6, math 9 that thing. There's your answer, and it tells us we're in cubic feet right there. So that's how much total snow fell into the ground in those 6 hours. Then part B, it says find the rate of change. Now, when I see that, I'm thinking derivative. It says find the rate of change of the volume of the snow in the driveway by 8 a.m. Now, a lot of times if they gave me like a total amount of snow equation, I would take the derivative to figure out, how fast that snow is falling or removing. But right here, it says rate of change. These are the rates of change equations already because it gives it away, cubic feet per hour, and then the G of T in cubic feet per hour. That's how fast that snow is either falling or being removed. So those are your derivatives, those rate equations, which means at 8 a.m., you just want to do F of 8 minus G of 8. That's how fast it's going to be falling onto the driveway at 8 a.m. That's how fast she's removing it at 8 a.m. So just calculate her work right there. F of 8, you're plugging in the 8 right there, and then the G of 8 is simply equal to 108. So you just subtract those numbers, and then boom, there's your answer right there. Now, since the original units were in cubic feet per hour, and then this is still going to be cubic feet per hour because you're just subtracting the cubic feet per hours right there. It's going to be the same. All right, now letter C. I think this will make sense once I explain it. The first time I was trying to do it from scratch, so I kind of used a slightly different approach to come up with this, and then I think I made it too complicated, but I eventually got this answer. And now I'm just going to try and use some common sense and try and reason this out a little bit there, right? But H of T represents the total amount of snow that she has removed from the driveway, all right? The total amount that she's removing from that driveway right there. So that's going to be involving something with like the integral of G, okay? Now, we got a piecewise function between 0 and 9 because the times are different right there. So I got my 0, 6, 6, 7, 7, and 9. Now, all right, so in between 0 and 6, I know Janet was probably sleeping. It says she didn't start removing the snow until 6 a.m. So in between 0 and 6, she removed 0 cubic feet of snow from that driveway. So that was the easy part. That was equal to 0. And then I knew if I integrate the G of T, that's supposed to give me from like cubic feet of snow, that's supposed to change it into just from cubic feet per hour to like cubic feet, give me a total amount of snow. But when I first thought about that, I was like, okay, if I integrate the 125, that's going to give me 125 T. And that's not quite right. Think about why that's not right. Because if I say that represents how much snow she removed in between 6 and 7, if you plug in, you want to come up with something where if you plug in 6.5 and plugged it into your equation, that's going to tell you how much snow she removed at 6:30 a.m., which means she's been removing snow for a half of an hour. But if you plug in 6.5 right here and you go 6.5 times 125, that's going to be she's removing the snow at a rate of 125 cubic feet per hour for 6.5 hours. And that's not how long she was removing snow. So what you needed to do is subtract out those 6 hours that she wasn't removing snow that quickly. Okay, so that's why I said, okay, the initial amount is like 0. She didn't remove any snow yet, and then she started moving the snow at a rate of 125. But that was only in between 6 and 7. So you got to try to subtract out those 6 hours leading up to that. Now it makes sense. If I plug in 6.5 right here, 6.5 minus 6, I'm going to get a half hour. Half hour times that 125 would give me how much total snow she removed in that half hour right there, right? That'll be our what are like 62 and a half cubic feet of snow right there, right? And then notice in between 6 and 7, that was 1 hour, and she's removing at 125 cubic feet per hour. So for that's 1 hour, that means at that time she removed the 125, and then she's going to start removing it more a little bit more slowly of the 108. But see, you got to subtract out the 7 hours leading up to that. So I'm going to do it. So like if I want to figure out how much snow she removed at 8 a.m., then if I plug in the 8 right there, 8 minus 7, hey, that means she's removing snow at that rate, 108 for 1 hour, but then she already moved that 125 feet of snow right there. So to me, that was like a hard problem. it kind of makes sense. Like once you already see this done, I will tell you the very first time I worked that out, I didn't go straight to that answer and kind of reason out like that. I kind of did an integral. Some of you might like this, some of you might think this is more confusing, so just ignore it. But I said, okay, in between 6 and 7, we started with 0. That I'm doing like an initial amount and then how much are removed in between there. So at t equals 6, right? We're used to those initial amount problems. We're saying, okay, that t equals 6, we remove 0 cubic feet of snow. And then since that was t equals 6, what I'm going to do is integrate from 6 to some t, some random time period. And that's going to tell me, and if I integrate that g of t like we talked about, I integrate that 125, then that's going to give us the 125 t or s or whatever. And you plug in the t, plug in the 6. See, when you go the 125, you plug in the top number minus, plug in the bottom number. It gets us that same type of equation right there. So you're doing like the initial amount at t equals 6, picking up where you left off, and then going to where you want to go. And then this t is represented sometime in between 6 a.m. and 7 a.m. And then since you removed 125 in that one total hour, then that's my initial amount here. So at 7 a.m., I removed a total of 125 cubic feet of snow. And then this was at t equals 7. So since that was at t equals 7, then I picked it up where I left off. So I'm integrating the derivative, the g of t. When I integrate the g of t, it'll go from cubic feet per hour to cubic feet. And so you're going from 7 to that random time period right there. And then notice when you integrate that, plug in the top number, plug in the bottom number, that'll also get you that t minus 7. So I don't know if that helps anybody else think of that, or if you just kind of reason out and go straight to the answer on something like that. Just, I thought that was a weird problem, so I figured it wouldn't hurt to kind of get you exposed to that there. I don't remember seeing something quite that weird and tricky on some of the last years of tested. I like these total type, but it's usually more straightforward how to come up with that. And notice if I was going in between like 6 and 8, and I was going at 125, if I was removing snow at a rate of 125 per hour for 2 hours, then my initial amount would have been like a 250 right there. All right, so there's that. And then the rest of that problem there, I thought was pretty normal. I thought letter C was the toughest part. Then letter D says, how many cubic feet of snow in the driveway at 9 a.m.? So at 9 a.m., you're going to integrate between 0 and 9. That's going to be the math 9 problem. That'll give you how much snow fell in the driveway in those 9 hours. And then the h of 9 represents how much total snow should remove during those 9 hours. So you're going to subtract out h of 9. And so that just means you're going to take the 9 and plug it in right there, because 9's in your equation right there. So then you got f of 9 minus the h of 9, and that's going to give you those cubic feet right there. Iced tea. Am I talking about the refreshing beverage or like the rapper / actor right there?